No, actually.
Just so you want to get that in so we can see it on the TVs?
Yep.
Yeah, we tested with mine. It was working fine.
Yeah.
What do you have your slides on?
Google Slides. I could check my settings.
Yeah. If it is, I can't get it to work. How do you feel about using my laptop?
I think that's fine. Displays. Sorry, let me see. Yeah, it's not, I don't think it's detecting it at all. It's not, it's just showing my display, right? Do you want me to try out?
Because we had his laptop in before, so it's your computer. Click on, well.
Yeah, I could borrow one of your computers. It's fine.
Yeah, okay.
Yeah. So. Do you have the Zoom?
The Zoom? I have Zoom. I don't have the link to this specific one. Sure. Sure. Yep, that works. Yeah, the thing is we tested with my computer about 10 minutes ago and it worked. It's not showing up at all now. gets power when I plug into the hub, so the hub's not the problem. I'm going to get another HDMI cable.
Bear with us, I'm sorry.
Oh yeah, no worries.
There we go. All right, you want to try your laptop again?
Yeah,
Thanks. There we go. Shit, well. There we go.
yeah.
Thank you everyone for coming today. Unfortunately, Yanqing, the primary organizer of Tea Time Talks for today, didn't feel okay to come, so I, as a secondary organizer, would moderate the session today. Today we have Michael Ogezi presenting improving aesthetics in text-to-image generation by reinforcement learning. Without any further ado, please Mike, take away.
Thank you, everyone. What's going on? Yeah, I'll just try not to touch my computer. So I'm going to be talking about improving aesthetics with reinforcement learning. This work is by me and Ning. So this is my overview. I'm going to start by talking about the aims of this talk, my motivation, the idea, the methods, our experiments and results. And I'll end with some takeaways I think are important. So I just want to say right off the bat, I'm not going to be trying to make any bold claims. I just want to talk about something that I personally think is cool and get some feedback from real RL people and talk about some non-standard cases we can apply RL ideas. So this is the motivation, right? We want to produce more aesthetic and high fidelity images. You can see the first image there's some characteristics we don't want. It's blurry, doesn't look focused. And the second one looks much better, and that's what we want. So I'm going to give a brief background.
You can click in that little corner, the upper left corner.
Okay. Yeah. Okay. So text-to-image models like Stable Diffusion.
And then let me give you one other suggestion.
Mhm.
All your friends and everything.
Yep.
Don't turn away from the microphone.
Okay.
Just look at your screen and talk to the microphone.
Okay.
It's much better if you look at your computer screen, because then you won't turn away from us. I like to see your face.
Okay. So text-to-image models like Stable Diffusion often produce images that are not aesthetic. Larger models and better data sort of alleviates but don't fix the core problem. And in general, we use prompts to describe images that we want. And we can also use negative prompts to describe unwanted characteristics. So I'm going to give a brief example. So these are some samples of images generated by Stable Diffusion. And we can see that with the, going to have to move this again. We can see that with the first prompt, the portrait of a man, we get some acceptable pictures of a man. And in the second prompt, we want to generate a pictures of a man that doesn't have a mustache. But we can see that the model mistakes what we mean and actually generates pictures of a man with a mustache. But when we use a negative prompt that has mustache in it, we're able to remove the mustache characteristics from the images and get what we actually need. So there are some cases where negative prompts end up being more expressive when we want to solve a task. So the idea here is to perform negative prompt optimization. Just like how we specify mustache in our negative prompt, we want to specify non-aesthetics. And in that way, we make our images more aesthetic. So given a prompt, we want to produce a negative prompt conditioned on that prompt. And we want to do this such that when we use both to generate an image, we have an image that looks more aesthetically pleasing than if we just used the prompt. So we have a okay, so the question is that since aesthetics are generally subjective, how do we measure them? So what we do here is that we have a supervised learning model that basically learns to assign a score between 0 and 10 to images based on how aesthetic they are. So you have a bunch of humans. So humans essentially assign scores. Yeah. Yeah. So we have three things that we care about here: aesthetics, alignment, and fidelity. And aesthetics, we've already spoken about that. Alignment simply measures how faithful the image is to the prompt. And fidelity measures how similar the image looks to a real image. So when we have all these metrics that we care about, we're interested in producing negative prompts that align with them, essentially. So we want to produce negative prompts that improve aesthetics while keeping alignment and fidelity good. So this is our... So fidelity is about how similar it looks to a real image. Aesthetics cares more about beauty. Yeah, so you can have an image that is aesthetic but not aligned, not high fidelity. it could have like lots of things depict like an actual concept, but it's not beautiful. It's like, yeah, exactly. So for example, if you have an image of, say, sorry? Well, if you have an image of, say, people in a hospital, right, that might be high fidelity, but it's not aesthetic. So on to the RL formulation here. So we have the state as our prompt, the action, the things we can do as the negative prompts, and the reward being the weighted sum of our image quality metrics. So we have this here. P is the prompt, P prime is the negative prompt, and based on these two things, we generate images that are scored. So I of PP prime is our image generator. S of X are scores indicating performance on aesthetics, alignment, and fidelity, and alpha, beta, and gamma are hyperparameters that correspond to those scores. So this is essentially what we want to do. We use our prompt, produce a negative prompt, generate an image with that. Then based on what our reward function says about the quality of the image, we update the language model producing the negative prompts. So a full method summary. We construct a data set of prompts and negative prompts. We fine-tune a sequence-to-sequence model to produce negative prompts when given prompts, and we further optimize to our preferences using reinforcement learning. And I'm going to speak a bit about why both components are important, that is fine-tuning and reinforcement learning. So our experiments, the specific sequence-to-sequence model we use is T5. We optimize using PPO. Our text-to-image model is Stable Diffusion. And these are the metrics we evaluate for: aesthetic score and clip score. Aesthetic score is, I described that earlier, but clip score is simply the similarity between the prompt and the image generated from the prompt. So we have a few baselines here. The first baseline is like no negative prompt, so how good is the image when we don't use any method for negative prompts. We also look at the ground truth, that is negative prompts produced by humans from our data sets. We look at a previous method called promptist that only optimizes the prompts, and we have these three variants of our model: supervised, fine-tuning only, reinforcement learning only, and the full method, NegOpt. So these are our results. You see that with NegOpt, we get much better aesthetic scores. We do considerably better than supervised fine-tuning, and we also do better than the ground truth. And I think this is really interesting because typically vision language is typically thought of as something that's a supervised learning problem. And with some RL that we add, we are able to do better on those metrics. So the second thing is clip score. So ground truth are negative prompts produced by humans. And in terms of clip score, what we actually want here is to keep our image aligned with the prompt. We just don't want this to degrade too much, essentially. So we can see that, as expected, without anything, we have the highest clip score. The ground truth has pretty high clip scores, and they just sort of increase. So I want to talk a bit briefly about what I think we can learn from this project. So we are able to produce images that are more aesthetically pleasing without sacrificing alignments. And by tuning how much, by tuning alpha, beta, and gamma, we are essentially able to say we prefer alignment more than aesthetics, or we prefer aesthetics more than fidelity, for example. These are some examples. We have this prompt. We have negative prompts that we produce, and we see that consistently we have better images with our method, even when compared to the ground truth. And finally, I want to talk about why RL makes sense here, because I think that's something that some of us will be curious about. So what it allows us to do is to concisely and easily specify what we care most about. And here, what we care most about is aesthetics. And we can specify that very easily with our reward function. And we are also able to prevent the degeneration of other metrics. So we are able to, we're able to maintain alignment to our prompts. So our takeaways: RL has potentially interesting applications outside of traditional areas. In some domains, which are traditionally supervised, RL can still do better than, RL still does pretty well. And we can take a model and simply adjust it to some preferences that we care about using reinforcement learning. Thank you.
Okay, time for questions.
Thanks for the talk. So I'm not quite sure if I understand how the RL was used. So I'm trying to think of what exactly the problem you're trying to solve is. And from your motivating slide, it was that when you give a prompt, something like, oh, give a portrait of a man without a mustache, it's just that the image generator cannot parse this properly. And so that's why it still produces images with a mustache. And so there is this thing called negative prompt that you can say, okay, not these things, right? And then your idea is that, okay, now we can somehow, given this prompt, automatically come up with the negative prompt so as to feed both of those things to the image generator.
Yeah.
And so I wonder if this is like a NLP problem where, like, sort of like a supervised model where given a prompt, given some input, you learn what are the negative things within it, like, with English words like without or not this or something like that. And that gives you an output of, all the like mustache or all of those kinds of words. And so this sounds to me like a supervised learning problem, right? Like you mentioned you had a data set of prompts and the negative prompts for that prompt. And so if you train like a supervised learning model to do this, that sounds plausible. So where does reinforcement learning come in? That if there is a supervised model that can do this, are you making it better through RL, or like how exactly is RL playing a role here?
Yeah, exactly. That's exactly what's happening. We are able to get a good start with fine-tuning. However, we are able to increase even further with reinforcement learning. So I will go back to the results. So what this is, so this is 6.28 is fine-tuning only, and 6.4 is our full method with fine-tuning and RL. We see here that RL on its own doesn't work very well. That's just because the space of things it want to predict, it's quite large. So it's difficult to learn that just by traversing the space of things you can predict. But when we start with supervised fine-tuning, we're able to restrict a bit what we are going to generate and optimize that even further later on.
I see. So the RL part is like the last fine-tuning, which is...
Yeah, exactly.
Okay.
It's very similar to RLHF.
Right.
Exactly.
Okay.
Yes, but what I'm trying to get at is that with this method, there is a synergistic property, right? The sum of both perform better than either separately.
Thanks.
Yeah, you're welcome.
question.
I think I've missed something major here that I'm not under. Well, there were many things I wasn't quite sure I understood, but one of them is, if the problem really is your parser can't figure things out, why not just fix the parser? I mean, why go to this? I've missed out. I'm sure I've missed something very obvious, because you've gone to all of this work to do these negative prompts. But if you have something that clearly you said without a mustache, and a simple parsing can't say, okay, without means no mustache, then I'm a little confused about.
Yeah. So this was just an example.
Yeah, but why
Well,
in general is that the case, where you say, okay, you know, here's a thing that you want or you don't want, and then you have to give the negative of that? It's sort of, I don't understand, I guess, why the
okay.
parser isn't better, and
Okay.
why people don't maybe work to do that rather than, anyway, that's my question, sorry.
Yeah, sorry, that's a very good point. I should have explained that earlier. So the idea here is that the prompts that we produce are supposed to latch on to specific characteristics that may be in images, right? And you are not always able to specify, like, the default behavior should be that when you say, I want a portrait of a man, it's like a good-looking image, right? And I'm going to sort of say that we're not directly speaking about mustaches, but we want something, we want to essentially remove the ugliness from images. And what we're trying to get at is that there might be some property in negative prompts that we are able to learn such that we represent that ugliness. It's not so much a problem of the text encoder as it is just finding a part of the latent space, for example, that produces good images. The reason why we have to do this, I think it's a stopgap. I think in the future we'll have better models. But the reason why we have to do this is because the data isn't really great. So you have prompts that are noisy, prompts that are not always aligned to images. There's some helpful knowledge there, but it's really noisy. So by doing this, we're able to sort of learn properties of noise that are not good and sort of add that to the model so that we don't do those.
So could you say something about your data set, how big it is and how many examples and stuff like that?
Yeah, so the data set is, well, the original data set is about 100,000 examples. We do filter the data set by the number of likes. So at the end of the day, we have 5,000 examples that we do supervised tuning on, and we do our evaluation on about 500 examples.
Thanks for the talk. So I was curious, when you trained the RL only agent to write the prompts, did it its performance plateau, or is it just like the search space is so big that it will keep getting better, but very, 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 very slowly?
Yeah, that's exactly correct.
Okay, so it slowly and slowly gets better.
Yeah.
Gotcha. Do you think there's any like exploration methods you could use here, or is it just, I mean, there's so many words that exist that you kind of have to just try them all sort of thing?
I'm not sure there's any direct exploration method, but as we show here, it's sort of the supervised learning that's, I don't know how, I don't want to butcher a term, but the supervised learning sort of helps it start. It bootstraps the prompt generation essentially.
One thing I wonder, if you did want to just do this with like RL only, for example, is I'm assuming you're predicting like one of, X word, one of n possible words. But if instead you use like an embedding space and instead of predicting words, you predict a continuous vector, and then you'd like map that to the closest word. If that would be like, give it some way to search that is not just try this, try that, try this, try that.
Yeah.
Anyways, I guess
That-
a suggestion more than a question. But.
Yeah, that was actually the first idea I had. I wanted to optimize continuous prompts as opposed to hard prompts, but that didn't work very well. I guess that's a bit of a harder learning problem than this.
So, you said the goal is sort of to not have non-aesthetic images. We want
Yes.
more aesthetic images.
Yeah.
And you're using Stable Diffusion version 2. Have you tried things with like new mid-journey models? They seem to be extremely good.
Yeah, Midjourney is pretty good. No, unfortunately, since they don't have a real API, I can't do that.
So
But
does this problem still exist, like having non-aesthetic images?
yes, so it's really helped by bigger and better models, like I said initially.
Okay.
So my guess is that Midjourney does a few things that make their models better. Maybe they don't do latent diffusion, so they learn directly in pixel space, and they have much better data than most other people, and they have a much bigger model.
Thanks.
Yeah.
So your reward function has the 3 components, and each action is sort of part of the negative prompt, right?
Mhm.
So if the RL agent finds a word that is like a high scoring on individual reward, what's to stop it from just keep like hacking that, constantly repeating it?
Well, there are a few things to consider here. So first, since this task is kind of indirect, we are optimizing text that is going into something else. Hacking is not too difficult, not too much of a problem in the first level. We want to prevent hacking in the second level. And what I've observed is that it doesn't really degenerate. Like, it degenerates, but it's not too much of a problem. The images at the end of the day are still good. And what that probably means is that for different images, the tokens that remove ugliness are similar for a large class of images. Yeah.
That makes sense. Thank
Yeah.
you.
Any more questions from the audience?
Just a quick clarification. So, is the negative prompt always only one thing, or could it be multiple things? Like, could it be without a mustache and a beard? Like, because then it becomes combinatorially harder for any model to output these negative prompts, right? So is it one thing or is it multiple?
Yeah, it can be multiple things. Like in this example, we have quite a few things, right? So we have multiple heads, multiple wolves close up, and what we generate with NegOpt is considerably long. So I think what I've observed when playing with things like clip is that as you go further down, the model sort of pays less attention to the things. So I'm assuming that if we cut off a draft or something like that, we don't see too much of a degradation as opposed to cutting off at like cropped image, for example. But yes, I think it's possible to generate long text, and there is always like some marginal improvement by generating more things. It just gets smaller the further you are from the beginning.
I see. Yeah, could you just leave this slide up for a bit?
Okay, yeah, sure.
It's very interesting. So the prompt is the thing on the left, and then the NegOpt is the one which automatically came up with a negative prompt from that prompt. So can you explain that a little? So why is elongated body, for example, a negative prompt from that prompt? Like, or why is long neck not allowed? Or
Well, there is a bit of a bias towards the things human beings tend to write, right? This is how negative prompts produced by human beings look. So it's essentially saying things we don't like red eyes, out of frame, draft, deformed hands. Stable diffusion really has problems with hands. And I suppose, going back to what Eden asked, we may be able to I suspect we can get even better negative prompts if we are able to do better exploration just with RL. But here, I don't have enough compute to do that, honestly.
And so the ground truth here is what humans have labeled as the negative prompt for this prompt.
Yeah, exactly.
Okay. Thanks.
You're welcome. And I wanted to mention a caveat. These images don't necessarily represent my personal perceptions of beauty. Just in case. Okay.
Just the last question from the chat.
Okay.
You can open up the chat to read as well. How does training a language model to do the task compared to using clip interrogator to generate a negative prompt per image?
I didn't try clip interrogator. No. I don't know how it will be used to generate negative prompts. I suppose I haven't thought very hard about that, but as I know it, clip interrogator is for captions, I think. But Mark, do you have anything else to say? Yeah, go ahead.
Yes, so the technique I was thinking of was generating the desired image through a positive prompt, and then generating a second image, but putting the entire positive prompt in the negative prompt, and then using clip interrogator in the second image, which is sort of essentially the opposite, so to speak, and thereby getting a negative prompt.
Yeah, that's an interesting idea. I didn't think of that specifically. I did, perhaps related to this, I did try using negative prompts as prompts, and the images I got were pretty scary looking, and I suppose that explains why this method even helps. But that's an interesting thing to try out in the future.
Yes, because one advantage, I imagine, of your approach is that the language model is easier to query, like computationally, than generating multiple images.
I'm not sure it gets easier to query. Yeah, but I'm not very familiar with how clip interrogator works.
Okay, well, thank you for your thoughts on that.
Yeah, no worries.
Okay, that's it today. Thank you, everyone.
Thanks a lot, Rich.